In this video, we are continuing with Learning Target 19. I can apply the properties of integer exponents, and we're going to be looking at what do we do when we have a base with an exponent also raised to another exponent. So if we look at our first example here, we have 5 to the third raised to the second power. So what this means is I have 5 to the third times itself twice, including that exponent, that 5 to the third. And we know that 5 to the third means 5 times 5 times 5. And then 5 to the third again is 5 times 5 times 5. So altogether, that is a base of 5 multiplied by itself 1, 2, 3, 4, 5, 6. 6 times. So we get 5 to the 6th power. If we did our product rule, which we talked about in a previous video, when I'm multiplying the common bases, remember I add the exponents. So that verifies that 5 to the third times 5 to the third is 5 to the 6th, because we do 3 plus 3. If we look at our second example, we have 7 squared raised to the 4th power, which would mean 7 squared times itself 4 times. And if we use our product rule, remember we are going to be adding all of those exponents because I have the common base of 7. So I have 7 raised to the 2, plus 2 is 4, plus 2 is 6, plus 2 is 8. So we have 7 raised to the 8th power. So the shorthand, or the quick rule, the power rule says when raising a power to a power, we're actually going to multiply the exponents. So if we look back up at our first two examples, 5 raised to the third to the second, it would be 5 to the 3 times 2, which is what gives us 5 to the 6th, which matches what we had originally figured out. And 7 raised to the second power, or 7 squared raised to the 4th power, it would be 2 times 4. 2 times 4 is 8. And that matches again the answer that we already got. As we've already talked about, examples with coefficients, you're first going to raise the coefficient to the given power and then simplify the variables with the power rule. So looking at our first example here, to raise the coefficient, so 2 is going to be raised to the third power. And then I'm going to simplify my variable. Now currently my variable has an exponent of 1. 1 times 3 is 3. So this would be 2 to the third power times a to the third power. If you wanted to simplify that even more, it would be 8 times a to the third power. In our second example, I'm first going to look at that coefficient. I'm going to raise that coefficient to the power, so 4 to the 4th power. A has an exponent of 1, so that would be a raised to the 1 times 4. And b has an exponent of 1, so that would be b to the 1 times 4. So when we simplify that out, we have 4 raised to the 4th power times a to the 1 times 4 is 4, and b to the 1 times 4 is 4. Again, if we wanted to simplify the coefficient, that would be 4 to the 4th power is 256 times a to the 4th, b to the 4th. Fractions can be a little tricky for many of us. However, I have two values. My base is 1/5, but in that fraction, I have a numerator and I have a denominator. So I am going to raise each of those numbers to the 5th power. So I would have 1 raised to the 5th power over 5 raised to the 5th power. And 1 raised to the 5th power, 1 times itself 5 times, is still going to equate to 1. And 5 raised to the 5th power is going to equate to 3,125. And that would be our simplified answer. So looking at our last one here, we have another fraction. Again, I'm going to raise each value in that base to the third power. So I would have 1 to the third power over 3 to the third power. 1 to any power is going to be 1. 1 times 1 times 1. And then 3 to the third power is 27.